This is all about the GCF and the LCM. GCF stands for greatest common factor. LCM, of course, stands for least common multiple. Now, let's first talk about what those are. I'm pretty sure you guys all have done this before, but let's talk about what those are. We take two numbers and I ask you, hey, what's the greatest common factor? What that means is what's the largest factor they both share. Now, if I think about 12 and 16, they have a lot of common factors. In fact, if I think about it, I'm like, hey, you know what? 2 goes into 12 and 16. That's a common factor. It certainly is, but is it the greatest common factor? That's the concern. Well, I don't know. If I think about it, they both have 4 as a common factor. 4 goes into 12. 4 also goes into 16. After that, we can go through and go, well, 6 goes into 12, doesn't go into 16. 8 goes into 16, doesn't go into 12. So we can play around like that, and after a while, realize that they each have common factors of 2 and 4. 4 is the largest one, therefore he's the greatest common factor. If we were then going to go to LCM, least common multiple, what we would do is probably list their common multiples. So, well, I shouldn't say list their common multiples. We should probably list their multiples. For instance, if I start listing the multiples of 12, you would have, well, 12, 24, 36, 48, 60, so forth and so on. I would keep going. 16 would have 32, 48, and at that point I'd be like, oh, guess what? Okay, there's no need for me to move on to 64 and so on. Right there is their first common multiple. Since it is their first common multiple, that is their least common multiple. So you look at that and go, well, that's pretty simple, pretty cut and dry. I have a feeling most of us could have looked at this and probably figured out GCF, probably also figured LCM out least common multiple as well. The problem is what happens when this occurs. What happens when I say, what's the GCF and least common multiple of 122 and 256? Not as obvious, is it? Okay? So, and we're not going to do that right now. Or, what if I said, what's the greatest common factor of 4a cubed b squared and 8ab squared? Greatest common factor. Or, what's the least common multiple? Now it gets a little confusing. So, we don't want to just have that, what's the greatest common factor, and have you guys, your strategy be, 4. I want a process that gets us there. So that's what we're going to learn today. We're going to do this process through our prime factorization. So hopefully you watch that video or know how to do that. If you do not know, I would stop this and go back to that before you continue here. So in order to do this correctly, we're going to talk about the intersection and union of sets, okay? We talk the intersection and union of sets. The intersection of sets means that if I have 2 sets of numbers, the intersection would mean what are their common values in that. So when I'm talking about this, let's talk about you having a set like A and a set like B. And don't get all worried about me saying set. It's just a group of numbers. For some reason they're together. You don't have to care about why they're together right now. But let's suppose I had the set 2, 3, 8, 9, 15. And then I had a set of 2, 3, 4, 6, 10, 15, and 20. So my question would be, what is the intersection and what is the union of those sets? For nomenclature-wise, if you care to know, we would write A intersection B that way. It's an upside down U. If you care, you don't really have to know that. So the intersection of these 2 sets would be, well, what's the set of numbers that would contain the overlap here? So all I would do is go, well, they both have a 2, they both have 3, they both have a 15. So the intersection of those 2 sets is 2, 3, 15. It's that simple. That's their intersection. That's what they share. Now the union, that's a little more, we used the regular old U for that one, by the way. Union is a little trickier. The union is the smallest set of numbers I can make that contains the elements in both of these. So if you follow me here, I'm going to make a set that has a 2, a 3, that covers the guys. Then it's going to need a 4 to cover this guy, a 6 to cover that guy, an 8 to cover this guy, a 9 to cover this guy, a 10, I need a 15, that will cover both of these, and then I'll need a 20. So that is the least amount of items in my set, or elements, that I can make that contains both these sets. In other words, I see all of these guys in there, I see all of these guys in there, and there's no extras that's not in at least one of them. Hopefully that makes sense. Now, you might look at that and go, okay, cool, I got it. I know how to do prime factorization. I know what the intersection and union of a set is. How am I going to make this happen? Okay, well, I'm going to show you. So if you make a prime factorization of two numbers, the greatest common factor is the intersection of those prime factorizations. The least common multiple is the union of those prime factorizations. Let me write that down so that you guys can have that. GCF. If you want to find the greatest common factor of two numbers, it is the intersection of the prime factorizations. Like I said, I'm writing this down, you should. The LCM is the union of the prime factorizations. That's it. So that's our strategy that gets us right there. Okay? All right, so let's take two numbers and let's find their GCF and their LCM using these prime factorizations. I'm just going to go ahead and pick two numbers. Let's go ahead and find GCF and LCM of 24 and 36. I have a feeling most of you are looking at that going like, oh, I can do that without doing this process. Remember, we're just trying to learn the process. We'll step up our game here in a little bit. So what I'm going to do is I'm going to use the prime factorizations of those numbers to find the GCF. So I'm going to list their prime factorizations right here. Okay? Prime factorizations come from those fancy schmancy little factor trees. So I'm going to go off to the side here. Actually, I can do it over here, can't I? So I'm going to go ahead and do the prime factorization of 24. So two numbers that multiply up to 24. Let's go with 2 times 12. 2 is prime, 12 is not. 12 breaks down into 4 times 3. 4 is not prime, 3 is. 4 breaks down into 2 times 2. They are both prime. My prime factorization of 24 appears to be 2, 2, 2, and 3. 2 times 2 times 2 times 3. We'll do the same thing. You can get a different color here for 36. Two numbers that multiply up to 36. Most kids, I do believe, think 9 times 4. Neither is prime, so we'll have to bust both of those guys. 9 is 3 times 3. 4 is 2 times 2. 3 is prime. 3 is prime. 2 is prime. 2 is prime. There's my prime factorization. My prime factorization of 36 is 2 times 2 times 3 times 3. Okay. Now I know you're like, this is a lot of work to find something I could have found. Just bear with me. Okay, they're not going to be so easy, so you want to know this process on the easy stuff. So the greatest common factor is the intersections of the prime factorizations. So all I'm going to do for GCF is I'm going to write down the intersection. Well, my intersection of these sets, they both share this 2. They both share this 2. And they both share a 3. So the smallest set of numbers that I can write that shows where they overlap on a 2, another 2, and a 3. So 2 times 2 times 3 gives me 12. And the greatest common factor of 24 and 36 is 12. Again, you probably could have done that without doing this, but we're trying to learn the process. Least common multiple. Least common multiple is that union. In other words, I want to write down the least amount of values I can to cover everything in there. Well, this guy has 3 2s and a 3. This guy has 2 2s and 2 3s. So the least amount of stuff I can put down is I would need 3 2s. That would cover these 3 and also cover those 2. And then I would need 2 3s. That covers these 2 and covers this. So basically, I see all of this in there, and I see all of this in there without any superfluous elements. Okay? That means extra numbers. So basically, I can look at this guy and go, oh, hey, look, 2 2 2 3. I see that factorization. Then I can go here and I go, oh, look, I see that factorization. There's nothing wasted. So that guy, if I go ahead and multiply that together, 2 times 2 times 2 times 3 times 3 is going to wind up giving me 72. That is my least common multiple. Again, I'm pretty sure you could have come up with this without doing this, but we need to know the process. All right, another example, next example. Now, hopefully when you look at this one, you go, ooh, not so easy. Yeah, we're going to find the GCF and LCM of 160, 124. No doubt you could figure it out eventually. Most of you would probably spend a lot of time going, guessing, checking, doing all that stuff. And that's not going to suffice us, because at some point it's going to be like, that's not going to work. Like, we're going to sit here doing that, I don't know, guess and check, and not be able to come up with. So, once again, we're going to find the GCF and LCM by doing our prime factorization. So, I'm going to do 160, and I'm going to do 124. I will start with 160, so I'm going to come over here. Don't spend a whole lot of time with that number, so I'm going to make it really easy. Anytime it ends in a 0, I like to do the whole 10 thing. That's 10 times 16. Neither one's prime, but it gets me started. 10 breaks down into 5 times 2. 16 breaks down into 8 times 2. So 5 is prime, 2 is prime, 2 is prime, 8 is not. Split them. 8 breaks down into 2 times 4. 2 is prime, 4 is not. It becomes 2 times 2. They are both prime. So now I have my prime factorizations. Wow, there's a lot of 2s. 1, 2, 3, 4, 5 2s. 1, 2, 3, 4, 5 2s, and a 5. Cool? So now I'm going to go ahead and do 124. That guy, well, it ends in a 4, so it probably has a factor of 4. So let's go 4 times, and I think that would be 31. Correct? 4 times 31. Well, guess what? 4 isn't prime. That has to break down into 2 times 2. So that 2 and that 2. 31 is prime. Interesting. Well, I can't do any. 124 is 2 times 2 times 31. Scary, right? Okay. Cool. Now, I want to find the GCF. Remember, the GCF is the intersection. In other words, what do they share? Where do they collide? Well, they both have a 2 here. They both have a 2 here. That's it. That means that their greatest common factor is that 2 times 2, which is 4. So the GCF is 4. Now when it comes to LCM, this one's going to be ugly. So LCM is that least amount of numbers you need. So it looks to me like I'm going to need, well, a 2, a 2, a 2, a 2, a 2. I'm going to need those 5 2s. Those 5 2s, 4, 5, covers these 5 and these 2. I'm also going to need a 5. I'm also going to need a 31. It's going to be a large number, I believe. So I'm going to punch it in my calculator. I'm going to save my time by doing 2 to the 5th times 5 times 31. I'm going to get 4,960. Yeah, I have a feeling if you sat down and listed their multiples, like 160, 320, 480, like you'd keep going for a long time. Like it's going to jump up quickly and the number's going to get ugly, and then you're going to have to do this one until they match. It's going to take a while, but it'll be at 4,960. So hopefully with this example, given that the GCF wasn't really big and the LCM was. I'm hoping you're seeing the benefits of the prime factorization method versus just sitting there thinking, trying, or grabbing a calculator and guessing, checking. That's GCF and LCM of regular old numbers.